Welcome to another terrestrial navigation video. Today we will be doing a chart plot. We are working on the Chesapeake Bay and we will go through a modified U.S. Coast Guard chart plot. You'll need a set of dividers, 2 triangles, pencil and eraser, and of course your trusty calculator. The first question on this chart plot is at 12:36, your position is latitude 37 degrees 17 minutes north, longitude 075 degrees 30 minutes west. Mark this position as a fix. Your course is 210 degrees true at 12 knots. So we need to first mark our position by a GPS fix. So we will use the latitude and longitude marks on the sides to mark this fix. I like to start with my latitude, so 37 degrees 17 minutes north. So we have 37 degrees 20 minutes up here. So we need to go down 15 minutes, 16 minutes, 17 minutes. Each of these colored blocks is a minute latitude. So we'll take our divider and you'll make it parallel to your latitudes. So I like to match up the 90-degree line with whatever meridian you're going off of. So this is 17 minutes. And because we're close enough to the edge, we can just draw one straight out. So this is our latitude line, and our longitude is 75 degrees 30 minutes west. So we find 75 degrees, and 30 minutes west is on a meridian, so we can just come down and mark this as our fix. 12:36, and it's marked with a triangle because it's a GPS fix. We are on a course of 210 at 12 knots. So we need to get our course. So we'll take one of our triangles, and there's numbers around it. So 210 is in the southwestern direction. So we come get our triangle into the southwest, and then we match it up, keeping the point where all the marks meet on the triangle, and match it up with the 210 line. This can be tricky, and it takes some practice to get it right. And then we will transfer this over to our mark. And you may have to do it a couple different times or a couple different ways to get it. So now that we have it over here by our point, we can make another mark with our pencil. And we mark our degrees as 210. And you'll need to extend this line later, but 210 degrees at 12 knots. And it's important that you mark everything. The next part of the question asks us to mark fixes at 1300 and 1330 DR. So a DR fix is just walking out the line. So I'll move this chart up. Now that we have our first fix, we will need to extend the original course line of 210 degrees. So we take our triangles, we line it up with the original course line of 210 degrees. And I'm lining up with the black line. So there's this thin black line at the edge of the triangle, and it just makes it a little easier and more precise when you're working with it, working with degrees, because half a degree can send you off course by 2 or 3 minutes, and for a Coast Guard exam that is quite a bit. So I'm extending our course. It's really easy to slip and make a mistake, so make sure you're careful when you're doing this step. So now that we have our course extended, we need to mark our 1300 and 1330 DR positions. So our original position was 1236. So 1236 to 1300. That is 24 minutes that we have traveled in time. 24 minutes at 12 knots. So you'll type into your calculator 0 degrees minutes seconds button, 24 degrees minutes second button, times 12, because we want to know the distance, so speed times time equals distance. I did time times speed equals distance. 4.8 nautical miles. So we'll mark out 4.8 using the side, because 1 minute of latitude is the same as a nautical mile. So this is 4 nautical miles, 4.8. There's these little hatch marks on the side, and those are the decimals. So 4.8 nautical miles will come up here to the top, and this is out of frame. And this is our 1300 position. Our next point is 30 minutes later. So 0.5 times 12 equals 6 nautical miles. You can also type into your calculator 0 degrees minutes seconds button, 30 degrees minutes second button, times 12, and it'll get you the same answer. So 6 nautical miles. You want to measure using that same latitude scale. Never use the longitude scale. And this is 6 nautical miles. So we'll come up to our 1300 position, and we'll come down. And that is our 1330 position. We will change course at 1330 to 225 degrees true. Label course line with the course degrees and speed. Part A of this question says, what is the true bearing of buoy 14 at that time? Part B states, what time will buoy 14 be abeam to starboard? This is the type of question that the Coast Guard likes to ask. It is asking if you're on course, essentially. At 1330, we're going to change course to 225 degrees. So this is a nice and easy course change. 225 is exactly 45 degrees from 180. So I'll move this over to my course line. Did it a little too low. This is my course line of 225. And we'll need to extend this quite a ways. Moving your triangles around is a skill that you'll learn with time. We want to know the true bearing of buoy 14 at 1330. So first we need to find buoy 14. And buoy 14, so we're here at 1330. Buoy 14 is right here. It's good to circle it sometimes so that it catches your eye when you're looking for it again, because we are using this for two parts of this question. So we want to know, what does buoy 14 bear? So we place our triangle, and the middle of our triangle is going to be at 1330. And then you want your black line to go through the bottom small circle of the buoy. And that'll be your bearing. And then you'll take this over to one of your meridians to measure what is the true bearing. I have the bearing is 265 degrees true for that part of the problem. And now, what time will buoy 14 be abeam to starboard? The easiest way to do this is on your new course, the 225, is to take your triangle and line it up with the course line. You want the middle of the 90 degrees to line up with the longer end of your course. It's just easier to do it that way, I find. And then you match it to the small circle underneath the buoy. And then you make a small hatch mark on your chart, on your course line. That is when you will be abeam, because abeam means that you are 90 degrees from the buoy. So the buoy is perfectly 90 degrees to starboard or port from you. This buoy will be abeam to starboard because you are going in this direction. And now we need to find out when that will be. We take our dividers and find the distance, and we will be using speed times time equals distance again. And we want to know how far this distance from 1330 to when we are abeam of buoy 14. So I've got the distance. It is 2.6 nautical miles. So 2.6 nautical miles divided by our speed, which is 12 knots, equals 0.216 hours. And if you just hit the degrees, minutes, seconds button, it'll convert it into minutes for you, and you won't have to do any calculations. And you get 13 minutes. So 1330 plus 13 is 1343. And that is the time that you'll be abeam of buoy 14. Question 5 asks, when you intersect 37 degrees north, change course to head for position latitude 36 degrees 58.5 minutes north, longitude 075 degrees 50 minutes west. What time did you intersect latitude 37 degrees north? So we want to know what time we intersect the 37 degrees north. I've moved the chart down again so that you can see this part. So our course line has reached the 37 degrees north, which is this latitude line right here, and wants to know what time did we intersect it. Unfortunately, I can't show you guys the latitude lines anymore because we're in closer to the middle of the chart, but you do have the longitude lines across the bottom. So 37 degrees, and it wants to know what time did we intersect it. So we'll take our last known point, 1330 or 1343, and determine the distance between those time points and this point here. So I'll measure this distance, and your dividers may not go the full way, so a good thing to do is to go over to your latitudes, measure out 5 nautical miles. It is a good thing to do, so right now I've just done that. This is 5 nautical miles. So we'll start at the 37 latitude, and we'll measure up by flipping our dividers. I'm going to the 1343 mark. So it was one flip, so it was 5 nautical miles and whatever distance this is. So I'm going to go ahead and measure that, which was 3 nautical miles and 3.35 nautical miles. So 5 plus 3.35 is 8.35, and that is our distance, 8.35, and you'll divide that by your speed in order to get your time, which is 41 minutes and 45 seconds. And you'll round that up to 42 minutes. So 1343 plus 42 minutes is 1425. 1425. Now it's time to head for position 36 degrees, 58.5 minutes north, longitude of 75 degrees, 50 minutes west. So we know the center line is 37, so we'll be just below that. So 37 degrees, 58.5. So I went ahead and measured that on the side. So we have our latitude, and it is near 7550, which is this parallel right here. So this would be 36 degrees, 58.5, and this line right here is the 75 degrees, 50 minutes. So I'm just going to make a score and then mark that with my pencil. So that is going to be our position we are aiming for. So we'll just take my divider, my triangle. I'll just take my triangle and mark that line that we changed course to. And now it says, follow the inbound traffic separation lane towards the pilotage area. So this is the inbound traffic separation side, and this one below it is the outbound. So we'll just be following the inbound into the pilotage area, and this is where you would pick up a pilot if you needed one for the area. A lot of times they're marked with buoy A, and I just like to have a line that's parallel to the inbound traffic lane. They do expect you to make a parallel line even though they don't say to do this. So the next part of the question is asking, what time will buoy NCA bear 180 degrees from you? So we need to find first buoy NCA, and that is this buoy at the top. It is a whistle buoy flashing yellow every 2.5 seconds, and that is noted on the chart. And we want to know when does that buoy bear 180 degrees? So this is an easy one to note. You just take your triangle, match it up with a meridian on that black line, and then you slide it over until the buoy small circle and your course line intersect. And there we go. So at this point is when the buoy bears 180 from you, and we want to know the time. So our last time was 14:25. We want to know the time here, so we need to find that distance again and do distance divided by speed equals time. So our distance is 1.9 nautical miles. So 1.9 divided by 12 equals 9.5 minutes. So 25 plus 9 is 34. 14:34. That is the time when NCA will bear 180 from us. Our next buoy is CBJ that we need to find. What time will buoy CBJ bear 180 from us? So CBJ, where is CBJ? CBJ is right here. And we want to know when CBJ will bear 180. So we'll do the same thing we did on the other one. We'll match it up with the nearest meridian and slide it over. And mark it. So right here is where we'll meet CBJ. So we need to find the difference between first from there to there. So 14:34 to our course change. To our course change is 1.3 nautical miles. And then the remaining amount that I've marked is 6.3. So 1.3 plus 6.3 is 7.6 divided by 12, and that is 38 minutes. So 38 minutes has elapsed since we marked our 14:34 position. So 34 plus 38, our new position will be at 15:08. Thank you for watching. Make sure to like the video and comment any questions down below. I'll do my best to answer them in a timely manner.